Good morning, everybody. Welcome to the session. My name is Dan, and I'm a technology evangelist at Microsoft. In this session, I want to take you on a whirlwind tour of Azure and build out a number of solutions so that you can get a feel for some of the things that cloud computing offers. Now, it's worth mentioning that we can't cover everything, but we will cover enough for you to be able to grasp the concepts and then be able to distinguish the difference between infrastructure and platform-based deployments. And this will really help you in the future when you're trying to decide the best technologies to use. Now, in the sake of transparency, I'm going to be doing this totally live, which means that things may not always go to plan. But this is what makes it real. If need be, we can troubleshoot, we can resolve any issues, and we can bring these demos to life. I'm just looking at the chat window now. Yes, you will get a copy of the presentation. I'm recording this, so I will send it out once finished. And there's a copy of the slides on my website, which I will show you all towards the end. So if we're ready, let's begin. So I guess the first thing that we need to establish is why. Why do people move to the cloud? I mean, what makes it so appealing? Well, there are many reasons. This could be down to hardware reaching its end of life. It could be down to needing to have a bigger global presence. It could also be down to wanting to pay as you use IT services instead of paying for the equipment up front. The one thing that is consistent, though, is the need for agility. In order to be successful, companies need to be able to build services faster. They need to be able to run services cheaper, and they need to ensure that they always have enough capacity to meet demand. What's more, security has become more important than ever as companies need to ensure that they're protecting both themselves and their customers from increasingly complex threats. This is what drives organizations towards the cloud. And as such, we break down the key benefits into four broad categories. These are agility, availability, cost, and security. Let's look at these in more detail. Now, the cloud offers massive advantages over on-premises deployments. And this is realized when we look at its agility. You see, we no longer have to guess how much capacity we need. We can simply turn it up and back down again as demand dictates. Think of it as a utility. Just as our gas and electricity demands change due to the seasons, so can IT resources through the cloud. What's more, we can enjoy the benefits of economies of scale. And what I mean by that is cloud providers such as Microsoft buy these resources in bulk. This itself comes with massive cost benefits to which the savings are then passed down to our customers. On top of this, we also have high availability baked into most of our solutions. This reduces the workloads of the IT professional and in turn increases business resilience. Finally, if we look at costs and security, Microsoft spend around $1 billion a year on security. We hire over 3,500 dedicated security engineers, and we detect around 6.5 trillion signals each and every day. This tied in with advanced threat protection that's powered by our state-of-the-art algorithms means that your assets have never been safer. Now, there are many ways that companies may decide to use the cloud. And it's worth highlighting that the cloud is a model. It's not a place, which means that it can be deployed to suit your individual business needs. The most common is public cloud. This is the deployment method most companies will use as it requires no specialist hardware or expertise to manage. Companies simply connect to the resources securely from the internet and pay for what's consumed. If we think about it, it's simple IT. Users don't require any deep technical skills and can usually build solutions by filling out a simple form from the Azure Marketplace. A private cloud, in contrast, is typically built to suit the needs of an individual organization and means that they will need specialists to both build and maintain the infrastructure. This not only comes with added IT infrastructure costs, but also the staffing needed to support it. The deployment method may suit companies, though, who've already invested in their own private data centers or wish to keep some level of autonomy. The third deployment method is hybrid, and as you can probably guess, it's a mixture of the previous two. Now, this deployment method provides companies with the maximum flexibility and as such is widely deployed today. Microsoft offer hybrid cloud solutions with our Azure and Azure Stack products. These solutions are also developer friendly with a unified code base, making it compatible between both types. So now we have a better understanding of the different cloud models. Let's look at the different cloud tiers. To do this, we really need to think about how things are done on premises. With on premises, you're responsible for everything: the hardware, the applications, and everything in between. You have to make sure that you have enough capacity. You have to make sure that your resources are secure and that you have fault tolerance. You also have to make sure that your applications remain patched, that the runtimes are updated, and that security remains a core priority. The point I'm trying to make is that if you wish to run an application, it's actually a very small piece of a very large and complex puzzle, which only gets worse when you begin to add in virtualization and hypervisors such as VMware and Hyper-V. Infrastructure as a service, or IaaS, takes away the need to maintain the underlying infrastructure and allows the customers to manage resources at the virtual machine level. The underlying network, storage, and servers become the responsibility of the cloud provider, which means the physical equipment is no longer a necessity. This model is sometimes referred to as lift and shift, as it allows companies to migrate existing workloads seamlessly across to a cloud service, whilst allowing them full autonomy over the core components of the deployment. Now, to be honest, this model takes on more of a remote hosting role. The customer is still responsible for patch management, security, and high availability, but they also have the greatest level of flexibility, which means that the model is particularly useful if you're running older application deployments that are unable to be modernized. Platform as a service, or PaaS, releases more responsibility to the cloud provider, and therefore the perfect tier for modern, born in the cloud deployments. This tier allows you to become laser focused on what matters, the end user experience, without having to worry about any of the underlying architecture. Often you will find this cloud tier to be cheaper. This is because you're typically paying per thread or service execution, and you don't need to pay for a running virtual machine to do so. Because of this, PaaS is fast becoming the deployment tier of choice. Our last example is SaaS, or software as a service. And for this, think things like Office 365. Today, for companies to enjoy the great benefits of communication, collaboration, and productivity, they need nothing more than a credit card and an agreement with Microsoft. This is the future for application deployment. And we see countless services adopting this new framework to make IT simple and accessible to all. So now we have a better understanding of the cloud models and tiers. Let's take a better look at Azure, and more specifically, Azure Resource Manager. Now, Azure has many different front-end experiences, and it's really down to personal preference how you choose to access the resources. For some, it's a rich graphical experience through the Azure portal. This method would allow customers to navigate through resources using the mouse and provision new resources through the marketplace. And the marketplace is like the App Store. For others, though, it may be a command line interface. And it's worth noting that Azure supports both PowerShell and Bash, the born-again shell. So you have your choice of deployment shells available to you. But maybe it's through Git or Visual Studio. Again, this is nothing more than a front end, so the choice is completely up to you. But this is made possible because of Azure Resource Manager, or ARM. Think of ARM as the management layer that talks to your front end and enables you to create, update, and delete resources. When ARM receives a request, it will authenticate and then send the request to the correct resource provider so that the resource can be provisioned. Azure also has a distinct hierarchy, which makes the deployment and management of resources simple. Starting at the top, we have management groups, which provide a way to manage global policies and compliance for your resources. It's from here that we would configure the rules of the company. Perhaps we need to make it ISO compliant or ensure that it meets the requirements of the payment card standards. By setting these policies at the management group level, we can be sure that all future deployments abide by the rules set. At the next level, we have subscriptions. These are used to group accounts and resources and also act as a financial boundary. We can set quotas and limits that enable us to strictly control the resources that can be deployed. Next, we have resource groups. These are the logical containers in which we place our resources and typically use as a life cycle boundary. Now, every resource that's created in Azure has to live inside a resource group, and it will typically hold the metadata and related information. Finally, we have our resources. These are the services that we provision. Think virtual machines, app services, databases, containers, for example. So before we jump into our first demo, I just want to have a look at one more slide. You see, this slide is important because it highlights the layout of the cloud, and this could affect your deployments. Let me explain. Now, at the top tier, you have your geographies. This is going to be America, Europe, Asia, for example. These host regions. If we look closely, we can see that the Europe geography contains regions such as North and West Europe, UK South and UK West, France, Germany, and Switzerland. Now, regions host data centers. These are the clusters of physical buildings in which we can place our resources. Each region will host multiple data centers, each of which is equipped with independent power, cooling, and networks to ensure high availability of our resources. Inside the data centers, we have racks. These are the physical components that host the blade servers. The blade servers then are where the resources are ultimately deployed. Now, how we deploy our resources will have a knock-on effect on the service level agreement that's associated with it. For example, if I choose to deploy a single instance virtual machine in the Europe geography and the UK South region, I can enjoy a service level agreement of 99.9% as long as I use and configure it with premium disks. However, if I need to ensure greater reliability, then I can deploy multiple instances of the virtual machine across different blades in different racks. This will increase my service level agreement to 99.95%. And it does this by introducing two new reliability considerations. These are update domains and fault domains. Now, an update domain ensures that our deployments remain on separate update schedules. Because like any physical components, the Azure servers may sometimes need to be cycled for update management. But an update domain ensures that this is staggered, and therefore we won't lose all instances. A fault domain, in contrast, ensures that our resources are spread across different blades in different racks. This decreases the chances of localized hardware faults and as such increases availability. But we can also further increase our reliability by deploying our resources across multiple physical buildings. As mentioned before, these have separate power, cooling, and networking, which means our service level agreement is increased to 99.9%. So again, just to recap, we can spread it across multiple blades inside a single data center. This will give me an availability set and push my SLA up to 99.95. It does this through update domains and fault domains. So we can see our fault domains, we've got 1, 2, 3. If our workload is split across, if rack 1 goes down, rack 2 and rack 3 continue to work. But we also have update domains. Blade 1s, Blade 2s, Blade 3s. So as Microsoft update the Blade 1s, Blade 2 and Blade 3 continue to function. If we want to further enhance this, we can replicate between physical data centers. This is called an availability zone and pushes up our SLA to 99.99. So with that, let's jump into our first demo. Now, this demo will be a quick look at the Azure portal and the Azure shell. And I'm going to show you this so you can get a feel for the different ways in which you can interact with the services. So let's go ahead and jump in. Now, I'm hoping at this point you are all familiar with the Azure shell. Where I am now is I'm in a dashboard, and I'm able to go in and create as many dashboards as I want. And this is typically a good idea if you want to break down departments or projects. To navigate in the portal, what I will typically do is I will go up and I will go into create a resource. Now, this takes me into the Azure Marketplace. And as I said before, the Azure Marketplace is like the app store for Azure components. From here, I can go ahead and search for the things that I want. So if I want a CentOS box, if I want to run Linux, I can just go ahead and say I want CentOS. And as I said before, it will open up a simple form that I can then go ahead and configure. But perhaps I don't want to use the Azure portal. Perhaps I want to go ahead and use the command line. Well, I can do this. If I click on a new tab, I can go to shell.azure.com. And if I go into shell.azure.com, if I log in to my account, then what you'll see is it will give me the option to either use the born again shell or PowerShell. So PowerShell if I'm more inclined to using the Windows command line, Bash if I'm more inclined to using the Linux-based command line. But no matter if I do it in shell.azure.com or portal.azure.com, it's still accessing the same resources. It's still using the same components. And this is made possible because of the Azure Resource Manager. Now, what I would say is when you're learning this, it's probably best to do it split screen. So from portal.azure.com, you can see that I can actually go in, and then from here, I can run a command line directly from the portal. So again, I might want to go in there and say, you know, AZ resource list output table, for instance. Then it will go down, it will have a look at what resources that I've got in here, and I can see all of the resources that are in my subscription. Again, if I go into here and browse through the command, the portal, we can see what it's showing me. So it's, look, it's showing the website and all of the components in there. If I click in the website, I can see the components that it's listing. So again, it's really up to you how you choose to navigate around the portal. But if I wanted to build something out, if I just clear that screen, if I wanted to build a new resource group, for instance, I could do something like AZ group create. I could put that in the location, Central US, and I could name this Accenture CLI. Okay, and that will go off and it will build me out my resource, and we can see that resource group has been created. But similarly, I can also go in and create a new resource group from here. I can go in and say what subscription I want to use. So let's say Microsoft Partner Demos. I can create a new resource group called Accenture. And from here, I can choose where I want it hosted. Now, again, I've got two options here. I can't choose the blade. I can't choose the rack. I can't even choose the data center. But what I can do is I can choose the geography, which is in the brackets, and the region. So I'm going to go ahead and I'm going to use the geography. Let's use the geography US and the region Central US. If I click next, it's now going to ask me, do I want to add some tags? And tags are nothing more than text labels. Okay, they're nothing more than text labels, but you want to get into the habit of using these because they become really handy when you want to do automation or you want to do cost control. So I'm going to go ahead and create a new tag called MSFT Partners. And the value I'm going to put in as Accenture. Okay, so from there, I'm going to say next, review and create. And we can see that validation has passed, and I can go ahead and press the create button. And that resource has now been built. So we can see that that resource is now pinned to our dashboard. Okay, that resource is now pinned to our dashboard. I can customize that resource and make it a little more manageable too. Again, all of this is totally customizable. If I click on edit, you can see there's a whole bunch of things that I can put on there. Okay, I can put in things like markdown. I can put things like metrics in there. I can put, I don't know why you'd ever put a clock on there, but you can if you need to. But things like markdown are really important. So if I drag markdown in there, what it will allow me to do is add my own markdown into my dashboard. So I could say, you know, this could be something like ING, SRC. And then what I could do is if I just find a link to it, let's bear with me a second. If I just go into my resources, I go into storage. Then what I could do is I could point to an image. So let's have a look at partners, and I'm sure I've got an Accenture logo in there. If I grab the Accenture logo, then what I can do is go in and edit this, paste that in, and we can begin customizing our dashboard with company logos and stuff like that. Okay, so we've done our quick demo. Let's jump back into our slides and think about building out our network. Now, this isn't going to be a deep dive on networking, okay? I just want to cover a few basics so that we can understand what it is that we're deploying in our next demo. And if you've ever done any networking in the cloud, you'll be pleased to know that the rules of networking don't change in Azure. So if you've got some experience, then you shouldn't have any trouble building out networks in the cloud. But what is it? Well, a computer network is very similar to a residential area. We have a bunch of computers and devices that share a network, just like we have a bunch of homes that share a postal code. The network, or the postal code in our example, is the transit backbone. And this means that when our devices wish to communicate, they identify if the destination is on the same plane. If it is, then great. They can send the message directly to the recipient. However, if it's determined that the destination is remote, then the computer has to package the message so that it can be delivered by a third party. So again, think, you know, it's Christmas time. You're sitting in your home here. You want to deliver your Christmas cards to your neighbors. If they're in the same street, chances are you're going to walk out your front door and you're going to hand post them into everyone's letterbox. But if you've got friends and family hundreds of miles away, you can't do that. What you're going to do is you're going to walk to the post box at the end of the road. You're going to post it into the post box, and then, you know, it's going to get delivered to the recipient. Now, you put it in the post box and you hope that it gets delivered. If you want to guarantee that it gets delivered, then you send it recorded delivery. And computers do that too. So again, you know, if we think about the postal system, we would mail a letter into the post box and then it would be delivered by the service. Exactly the same when it comes to computer networks, but obviously we don't call it a post box, we call it a router or a default gateway. But what's important is that we understand the addressing scheme. Now, there are two types of IP addresses. We have IPv4 and IPv6. They largely both serve the same purpose, but IPv6 networks have much larger capacity. For the sake of our demo, we'll focus on IPv4. This is a 32-bit value that's broken down into 4 lots of 8-bit segments. Now, again, don't worry too much about the binary maths at this point. Just know that these 32 bits are represented in decimal, so we will typically see 4 values between 0 and 255. Let's take a look now. Look, if I go in, if I open up a command prompt, okay, so if I open up a command prompt and type in the command ipconfig, okay, so there we go. So if you do that on your computer, you should see a decimal value similar to mine. So I've got 2 addresses. I've got IPv4. This is a 32-bit value, which is notated in decimal. But I've also got IPv6. This is a 128-bit value, which is notated in hexadecimal. Okay, so hexadecimal, each one of these values represents 4-bit binary. So this is the unique address that machines use to talk to its peers on the same network and decide which messages it needs to route. But how does it know this? How does it know if it's on the same network or not? Well, this is the job of the subnet mask. The subnet mask decides what percentage of the 32 bits represent the network and what percentage of the bits represent the host. From here, you can see that my subnet mask is 255.255.255.240. And this means that 28 of the 32 bits represent the network and only 4 are used to identify the host. Again, don't worry too much about the maths at this level. It's not going to be in the Azure Fundamentals exam. It's just so we can understand what we're going to build out in a moment. And I will put some calculators up on my website, you know, if you wish to learn more. But for now, we just need a basic understanding. The one thing that I do want to point out, though, is that you won't always see a subnet mask. We often abbreviate it to make life a little easier for ourselves. So instead of typing out the full IP address and subnet, we will often use something called CIDR notation. Now, CIDR stands for Classless Interdomain Routing. And it's nothing more than a slash at the end of our IP address, along with a decimal value, indicating how many of the 32 bits are being used to identify the network. So again, here I've got 255.255.255.240. And if you cast your minds back, we said that that's 28 bits out of the 32 that represent the network. So instead of doing 255.255.255.240, I could have just put 172.17.193.86/28. So with that, let's jump back into the portal and we'll build out our network. So back into the portal, what I'm going to do is I'm going to go into my resource group. Okay, and from my resource group, just before we start building out our network, let's take a quick tour of the resource group. Now, like I said, every resource that we create has to live inside a resource group. Okay, from the overview, I can see all of the resources that have been deployed in there. I can see the subscription that it's in. I can see the tags that have been added. If I come down, I can see any activity that's happened. I can also control identity and access management, IAM. And this is who can do what inside that resource group. You can see I've got my tags and any events that have happened. If I come down, we can see that I've got any deployments. And obviously, there's no deployments that have been done. But I can also set policies. Now, policies is where I start setting the rules of the company. Here I might say, well, okay, you can create virtual machines, but they have to be running Linux. And the virtual machines have to be on this particular network. And the machines have to be this certain size. And the machines have to turn off at this point in the day. You can also see that I've got things like cost analysis, cost alerts, budgets. Now, again, cost analysis, this ties in with our tags. You know, you want to get into the habit of using tags because when I start to look at how much a project has costed or, you know, how much I've spent on a particular session, then what I can do is I can run cost analysis against the tag. Cost alerts allow me to set, alerts once I reach a threshold. Budgets allow me to create a cutoff point for how much money I'm willing to spend. Advisor recommendations. This is where Microsoft AI starts looking at the resources that we've deployed. And what it will do is it will start making suggestions on how you can make it more secure, how you can make it more efficient, how you could make it run cheaper. I'm just looking in the chat window and someone's asked, what is a tag? So all a tag is it's just a label. Just think of it as a text label. You know, when we put in the Microsoft Partners Accentures, they're just words. There's nothing special to them, but where they hold their value is through things like automation and cost analytics. So let's say, for instance, at the end of the month, my boss says to me, well, how much have we spent training Accenture over the last few months? Then what I can do is I can run a simple query that looks for the tags, MSFT Partners, Accenture. And then what it will do is it will tell me how much money has been spent to those resources that hold that tag. Or let's say today that I, spun up 10 virtual machines. And at the end of the day, I could go in and individually shut down each of those virtual machines. But if I tag them, then I could write a simple script that say, right, any resource that has this tag, shut down at this time. So they're really, really powerful for helping you automate, for helping you track and helping you keep on top of cost control. Okay, so let's go ahead and build out our network. Now, in the sake of transparency, this is running a little slow today. I'm running this session from a virtual machine. So if it is a little bit laggy, I do apologize. I'm going to go in and click on Add. And from here, what I'm going to do is from the marketplace, I'm just going to search for a virtual network. We can see virtual network is there. And again, a virtual network, create a logically isolated section in Azure with this networking service. You can use it to securely connect to your on-premises data center or a single machine using a VPN connection. Virtual networks make it easy for you to take advantage of the scalable on-demand infrastructure of Azure while providing connectivity to data and applications on premises, including systems running Windows, mainframes, and Unix. So again, a network is just where we're going to host our resources. So I'm going to go ahead and say create. And this is going to open up a form. And from here, I need to choose what subscription I want to use and what resource group I'm going to put it in. And again, remember, the resource group is the lifecycle boundary. So everything that we're going to create today is going to sit inside the essential resource group. I'm going to call this Accenture VNet. Okay, and I'm going to make sure that the virtual network is going to be put in the geography US in the region Central US. From here, I'm going to say next for my IP addresses. Now, I need to give this an address space, and I'm going to put this on the address space 192.168.10.0/24. Now, remember, there's 4 bits to an IP address, the 4 octets, 192.168.10.0. And my subnet mask here would have been 255.255.255.0. But again, I'm abbreviating it by just saying 24 bits out of the 32 will be used to identify the network, which means the last 8 bits will be used to identify the host. So all of this is the network. And this bit here will be the last bit will be the host. Okay, so I've got the ability to have 254 houses on this postcode. But I don't want to do that. I want to break this down a little bit more. So I'm going to subnet the subnet address space. So to do this, I'm going to click on Add Subnet. And I want to call this production. And in my production subnet, what I'm going to do is I'm going to take a little bit of this address space. So I'm going to say, okay, I want to use 192.168.10.0, and I'm going to half it. I'm going to half the amount of addresses. So up here, I had 256 available. I'm going to say, right, I want 192.168. That's better. Just type that in again. 192. Production. We'll put that in 192.168.10.0/25. Okay, and we can see, look, that's going to give me 128. So effectively half of the address space here. But I'm going to go ahead and I'm going to create another subnet because I want to reserve some addresses for development. I want my R&D team to be able to create resources on a separate subnet of my network. And again, I'm going to enable 64 addresses for R&D. Now that leaves me 64 addresses left that I can then use at a later stage. So with that, let's go ahead and say next for security. Now from here, do I want to enable distributed denial of service attack protection? And do I want to enable an Azure global firewall? Now, I'm going to leave these at the defaults. And the reason I'm going to leave these at the defaults is because I'm purposely going to make some silly errors as I build out my resources. And the reason I'm doing that is because later on in the day, I want to show you how Microsoft Artificial Intelligence is going to flag those issues and then make suggestions on how I can make my deployments more secure. Okay, so for now, I'm just going to leave it as the defaults and I'm going to say next for my tags. So again, I'm going to go ahead and I'm going to say it's my Microsoft partners, and this is Accenture, and then I'll say next for review and create. Now, once validation has passed, I can go ahead and press the create button. And we'll see that the deployment begins to initialize. Okay, so we can see the deployment is underway. And that's now complete. So from here, I'm going to go back into my dashboard, into my resource group, and we can see that I've now got Accenture VNet. In fact, let's go ahead and now pin that to the dashboard. So we can see that I've got my Accenture VNet. If I go into the Accenture VNet, again, we can see I've got no currently connected devices. But like before, I've got my activity log, my identity and access management. I've got my tags that I can configure. I can see my address space. I can see any connected devices. I can look at my subnets. And I can go ahead and if I choose to put on enhanced distributed denial of service attack protection, I can do it. I can go ahead and set my firewall. There were 5 IPs reserved by Azure. What's that used for? That's a brilliant question. So the reason there were 5 addresses reserved is because they're going to be used for the back-end routing between Azure. So again, if I've got my virtual machines sitting on my virtual network and I want to configure a gateway to go back onto my on-premises network, then those 5 addresses will be reserved for the routing between the 2 entities. So that's why you always get a few held back. If I come down, we can look at things like DNS servers. Now, at the moment, I'm using the default DNS server. But again, let's say I wanted to connect onto my on-premises network. Let's say that I wanted to sort of run a hybrid environment. Then chances are I've already got a DNS server on premises. So what I can do is if I point it to the on-premises DNS server, then I would get fully routed name resolution. If I've got multiple, VNets in Azure, then what I could do is I can set up VNet peerings. And then what that does is instead of me having to create gateways and routers, it will just use the Azure backend. So we'll come back and we'll have a little look at this a bit later. But for now, let's jump back into our slides and let's look at building out our virtual machines. So as we discussed earlier, virtual machines sit inside infrastructure as a service territory. They give you lots of flexibility without having to purchase any physical tin. But this also means that you have the responsibility of setting up and maintaining the builds. You have to think about the name, the size, location, configuring updates and availability, not to mention securing it all. These are great if you want to perform simple migrations across to the cloud, and they do support legacy applications, but they can also be cumbersome deployment methods, due to lack of agility. I mean, if we think about it, what do we really want? We want to run and allow access to an application or service. The virtual machine in this instance is simply the mechanism that allows that to happen. Fortunately, we do have another option, and it's one that's gaining popularity. Containers. Now, containers are a lightweight component of virtualization. They allow you to run an app and all of its dependencies without having to worry about compatibility and the underlying operating system. Now, you can't cross operating system types. They're not magical, but they will ensure that an application works on top of different versions if the core is the same. And we all use containers each and every day. Look at your mobile phone. You see those apps? They're containers. But we also need to think about the sizing of our virtual machines. Now, this can seem a little overwhelming when you first look at them. But instead of worrying about all of the letters, just think about the workloads that you wish to run. We have the general purpose virtual machines, which offer a balanced CPU to memory ratio. Then we have the compute optimized machines, which are perfect for app servers and network appliances. We have the memory optimized machines, which are suited to databases and in-memory analytics. We then have the storage optimized, which aligns to NoSQL databases and big data. We have the GPU optimized, which help render video and train AI models. And finally, we have the high performance builds that offer some of the most powerful VMs in the industry. So let's jump into a demo and start building out our virtual machines. Now, I'm going to build two. I'm going to build a Windows server, and then I'm going to build a Linux machine. Both will be hosting a website, but I will configure the Windows server manually, and then the Linux machine I'm going to configure to run a Docker container so that you can see the different deployment methods in IaaS. But regardless of the deployments, it is important to remember that this is infrastructure as a service. So the responsibility of configuration lands fully on our shoulders. Right, let's go ahead and build this out then. So I'll take a little bit of time to do this. We'll build two virtual machines out, but let's see how we get on. So again, I'm going to go into my resource group. From my resource group, we can now see that I have my virtual network under my deployments. So I'm going to click on Add. That's going to take me into the marketplace. And from here, I'm going to come down to Compute, and I'm going to say that I want to build a virtual machine. So as the form opens, again, I'm going to choose the subscription and the resource group that I want to use. And I'm going to be really creative and call this virtual machine VM1. I'm going to make sure that the virtual machine, like before, is going to go into the US geography and the central US region. And now I've got my availability options. And again, cast your mind back to the slide that we looked at earlier. This is where we're talking about where we're going to put this. So if I say I want no infrastructure redundancy required, it's just going to go into the central, the US geography, the central US region, and then it will pick a data center, it will pick a rack, and it will pick a blade. We won't get any choice on that. Now, this will give me an SLA of 99.9 as long as I use a premium disk. If I choose an availability set, we can see that what's going to happen is with an availability set, it's going to go into a single data center, but it's going to go into different racks in different blades. This gives me my update domains. It gives me my fault domains. If I choose an availability zone, then what's going to happen is it's going to go into the region, but it's going to go into separate physical data centers. And again, they're equipped with independent power, cooling, and networking. So my SLA jumps up to 99.99. So for the sake of time, I'm going to say no infrastructure redundancy required. For my image, I'm going to go ahead and I'm going to say, let's have Windows Server 2019 data center. Now it's asking me, do I want this to be an Azure Spot instance? And this is important when it comes to costing. In fact, let me just take a quick detour and show you some of the options that we've got. So if I go into www.azure.com, if I go into the pricing, and if I go into pricing calculator, let's go ahead and add a virtual machine. So I've added a virtual machine. And if we look at this, if I host this in West US and I run this for 730 hours at D2V3, that's 2 virtual CPUs, 8 gig of RAM, and 50 gigabytes of temporary storage, I can expect to pay $152 a month. But that's only if I'm running it for 730 hours. If I change the amount of hours I'm using, that price will change. And this is where we have to start thinking about cloud computing. You see, in the past, we brought the machines that we thought that we needed, okay? And then we were bound by the resources of that physical tin. But in the cloud, that changes. You know, if I'm using this to run a complex report, instead of running a machine with 2 cores and 8 gig of RAM that may take a week to process it, then what I could do is I could run a much bigger instance of a machine that processes it much faster, and I don't have to run it for as long. So you'll often find that you can do tasks faster by throwing more resources at it, and it still costs you the same amount of money because you don't need to keep it up and running for as long. Now we can see that this is £152 a month because I'm using pay as you go. But if I decided that this was something that I needed to run indefinitely for a year or maybe more, then I can create reserved instances. Now, reserved instances are like a mobile phone contract. You know, if you're using a pay-as-you-go SIM, it's more expensive than if you have a monthly contract. So if I sign up to a contract, we can see the price begins to reduce. If I sign up for multiple years, we can see the price begins to reduce. We can also see that, you know, if I'm an enterprise customer, then I already own the license. So I don't need to pay for the license again. So that machine that was originally going to cost me $150 something a month is actually going to cost me $37 a month. Okay, so there's massive cost savings to be had. And quite frankly, when we talk to people and they say, you know, I price something up in the cloud and it works out way more expensive, 9 times out of 10, it's because they've architected the solution wrong. So just something to be aware of. Now, what does this have to do with spot instances? Spot instances are another payment solution in Azure. And that's say you wanted to run something and it doesn't matter when it runs. It just needs to run at some point in the week or in the month or so on. What you can do is you can use an Azure Spot instance, and they come with a massive, massive price discount because you just use resources when they become available. If someone else needs the resources, they get preference, but that's fine. Yeah, so you save massive amounts of money on that. So I'll leave this as it is, a standard D2 V3, so 2 CPUs, 8 gig of RAM. I'm going to go ahead and I'll give this the username Azure admin, and I'll give this machine password. And now from here, I want to make this a web server. So I need to go ahead and I need to open up certain ports. Now, the first port is going to be open is port 3389. This is the remote desktop protocol. This is how I'm going to connect into that virtual machine so that I can configure it. And Azure is quite rightly saying that I'm an idiot, that I shouldn't really be leaving this port open and exposed to the internet. But again, I'm going to do that because I want Azure Security Center to pull me up on this later in the demo. I also want this to be a web server, so I'm going to open up port 82. I'm going to say that I've got a hybrid use benefit because of my enterprise subscription. And then I'll say next for disks. Now look, I'm going to use a premium SSD. Watch what happens if I choose a different type of disk. I'm going to lose that 99.9 SLA. And when I said with single instance machine, you'll get a 99.9 SLA, but only if you're using a premium managed disk. I also get to choose what I want to do with disk encryption. Okay, and I'm going to leave the default setting of encryption at rest with a platform managed key. I can add additional data disks if need be, but for our demo, I'm just going to say next for networking. Now from here, it knows that I've already got a virtual network and I can choose what subnet I want to put that virtual machine into. So I'm going to put it into production. I'm also going to give it a new public IP address so that people from the internet, i.e. you guys, will be able to access the website when it's up and running. So we'll leave it as that. And I'm going to come down and say next for management. Now from here, do I want to enable things like boot diagnostics and OS guest diagnostics? This will send telemetry information into a storage account that would allow me to then go back and troubleshoot if there's anything wrong with a build. That's way out of the scope of the exam and today's session, so I'll turn those off for now. Do I also want to enable auto shutdown? You know, I can get these virtual machines to automatically shut down and start up at different times. In fact, you know, with the lockdown, I built my son a Minecraft server because I wanted to control who he was playing with and how long he was online. As far as my son's concerned, at 9 o'clock, the cloud goes to bed. He will get a message about the machine shutting down, saying that it feels sleepy at 8:45. Then at 9 o'clock, the server just closes down. At 10 o'clock the next morning, it will start up again as long as he's done his homework. So you've got real resource control here. And it's the same with backup. Now I'm going to leave that as off because I want to show you the backup once the machine has been deployed. If I say next to go into advanced, here's where I can add things like extensions. So I'm going to go ahead, and because I'm putting this live on the internet, let's go ahead and put in Microsoft anti-malware. So we'll go ahead, we'll put in Microsoft anti-malware, we'll accept the defaults, we'll say next for our tags, and like before, I'm going to put in MSFT partners and Accenture. Now it's worth noting, although I'm creating a virtual machine, it's actually creating 11 separate resources. It's creating shutdown schedules, availability sets, disks, network interfaces, public IP address, storage accounts, virtual machines, and so on. And it does this in a piecemeal fashion because if there's a problem with the deployment, I can fix the broken part. I haven't got to replace absolutely everything, which means that repairing and subsequent builds are that much faster. So with that, let's say next to review and create. We can see that validation is passed. So I'll begin creating that virtual machine. So we'll just give that a second for it to build out. And we'll build our Linux machine as the deployment starts. So in a moment, what we'll see is this start to populate with the resources that are being created. There we go. We can see the resources starting to build out. And that deployment shouldn't take too much longer to build. So while that's building out, I'm going to go back into my dashboard. I'm going to go back into my resource group. And I'm going to go ahead and click Add to go back into the marketplace. Now from here, I want to build a Linux machine. So I'm going to look for a CentOS Linux machine. So CentOS 7.5. So let's go ahead and hit Create. And like before, I'm going to go in and choose what I want. So I'll call this one Virtual Machine 2. I'm going to put it into the US, Central US. I'm going to use the standard machines before. Now, again, with Linux, you can use secure shell keys, but I'm going to use a username and password combination. So I'm going to say Azure admin. Like before, I will configure it with a password. And then I need to configure the ports that I'm going to open. Now, Linux obviously doesn't have a graphical user interface. So I'm going to have to use the command line and secure shell to access it. So I'm going to open up port 22 and port 80. I'll say next for disks. I'll leave those defaults. Like before, I'm going to go ahead and put it into my production subnet. I'm going to go ahead and give it another public IP address. I'm going to turn off the boot diagnostics and auto shutdown. And I'm going to add my tags as MSFT partners and Accenture. So from now, like before, we'll wait for validation to happen. We can see validation is passed. So let's go ahead and hit create. And we'll just wait for that deployment to start building out too. Now, the reason I'm showing you this is I want you to see all of the steps that you have to go through when you're using infrastructure as a service. And then as we move into platform services, you should see that it's an awful lot easier to build this stuff out. So we'll leave that running in the background and we'll go back into our dashboard. Now from here, we can see that virtual machine 1 is now deployed. If I click on virtual machine 1, it's going to take us into the resource. It's going to show me that I've got what resource group I'm in, that the virtual machine is running, the size and the operating system that it's using. It's going to show me my public IP address and my private IP address. So if I copy that public IP address and open up a new tab, remember I want this to be a web server, so I'm going to paste that in. And what we should see is it's going to come back with an error. And the reason it's going to come back with an error is because although I want this to be a web server, it's not going to be anything until I configure it to be a web server. So it's going to come back with a, I can't find that page. And again, I'll paste this in the chat window in case you want to do this back home too. You can see this page cannot be reached. So that's fine. We know that we need to configure this machine. Again, if we look, we can see activity log, identity and access management. But if I come down, we can see networking of the virtual machine. So from here, I can see the ports that are open. I can see my public and my private address. I can see any security that's been set up. I can see the disks that are on that virtual machine. I can change the size of the virtual machine if need be. And if I come down, I can do things like set up auto shutdown. I can configure my backup policy. So from here, I can say, well, okay, I want to start a new backup policy, and I can choose, you know, my daily, weekly, monthly, yearly backup routines. I can also set up disaster recovery. Now, what this allows me to do, this goes one stage further than availability sets and availability zones. This allows me to create a whole replica in a complete region. So if you've got an availability set, if you're using an availability zone and you are in multiple regions, then I would argue it's nigh on impossible to lose that resource. And if you do find that you lose 2 regions, then I would argue that IT is probably the least of your worries, because the world is probably going to be ending. Okay, so the point I'm trying to make is you're rock solid as you move up the stack. Now, again, because it's infrastructure as a service, it's your responsibility to do all the patch management. That being said, Microsoft do allow you to run a update service directly from the cloud. So if I enable this service, it will look at what security patches are missing on that virtual machine. It will then allow me directly from the portal to do the updates from here. The same with things like inventory and change tracking. Again, if I make this a virtual machine, once I've installed those services, it's highly unlikely those services are going to change. By enabling inventory and change tracking, if changes do happen, then it will notify me. And these could potentially be indicators of attack. I can set up things like configuration management. Now, this is using something called DSC, desired state configuration. Okay, with desired state configuration, here's where I can say, right, I want this machine to be a web server. If someone tries to change that configuration, it won't allow that to happen. So with that done, let's go ahead and connect into these virtual machines. So I'll go back into my dashboard. And what I'm going to do is I'm going to open up a Microsoft Terminal Service connection. Now from here, I'm going to paste in that public IP address and connect into that virtual machine. And again, I'll use my username and password. This is where the demos will go horribly wrong because I've always put in the wrong password. But I'll put in my username and password. Oh, we're lucky. And on this, we'll say yes. And now we're connected into that virtual machine that we just built in the cloud. Now, what's going to happen is it's going to come up with the default settings. It's going to ask me to, on this side here, accept my network settings, and then it's going to open up Server Manager. And that's the toolbox that I use to configure this machine. So we'll just wait for it to wake up. My network should pop up any second. So no to that. Server Manager is going to start. And it's from here that we can now start configuring our web server. So what I'm going to do is we're going to go ahead and we're going to install the required components here. Now, while that's initializing, I've already gone ahead and built a website. So I've created a simple website that we're going to host for today's session. Okay, so we'll go ahead and we'll host that on our server. So to do this, from Server Manager, I'm going to say Add Roles and Features. Let's say Next, Next. Now I want it to go on this virtual machine 1, and the server role that I'm going to add is going to be a web server. So I'll say web server and add the features, and then I'm just going to next through this wizard, accepting all the defaults, and press install. Now that's going to take a moment to build out. It needs to connect to the internet and download a few components. But when it's done that, what's going to happen is it's going to create me a folder structure. So what we'll see is on my C drive in a moment, I should get a new folder called inetpub. And in inetpub, I should get a new folder called www.root, and that's where I'm going to host my web page. Just wait for it to build itself out. There we go. So there's my inetpub folder. There's my www root folder. I'm going to delete the default pages. And what I'm going to do is I'm just going to go ahead and copy this website into the folder. So that's now going to be hosted on this virtual machine. So no, this one is a Windows machine. We set up a Windows machine and we set up a Linux machine. So the question was, how comes you used RDP into the virtual machine? Was it not set up as Linux? We set up two. We set up a Windows machine, which is what I'm in now, Windows 2019 Data Center. And now we're going to connect into the Linux machine once this is done. So the Windows machine, that's now finished. So let's come out of this. And what we should see is, my build a company in a day website is up and running. Okay, we can see the website is now live on the internet. So if you click on the IP address I've pasted in the chat window, you can see that the website is now running on a Windows-based machine. So with that, let's go ahead and now configure our Linux machine. Okay, so to do this, what I'm going to do, so I'm going to connect into VM2. And we can see again, I've got a public IP address. Now, I can't RDP into a Linux machine. So what I'm going to do is I'm going to open up my Cloud Shell. And I'm going to SSH directly in to this Linux machine. So I don't need to install PuTTY or anything like that. I can do it all from here. So I'm going to go SSH Azure admin at, I'll paste in that IP address, press enter, and it's going to say, are you sure you want to connect like the Windows machine did? I'll say yes. And again, for the sake of transparency, this is where it could go horribly wrong. It does every other demo, but let me see if I got my password right this time. Oh, I did. There we go. So we can see, look, Daniel at Azure. So I was currently in Azure, and now I'm sitting inside that Linux virtual machine. So I'm now directly inside this Linux virtual machine in the Cloud Shell. Now, for the sake of transparency, I don't want you watching me typing out a whole bunch of commands. So I've created a little text file for Docker. We'll talk through what's happening. But it just saves me having to type all this stuff out. So the first command that I'm going to run is sudo yum install, and I'm going to install 3 little packages. And think of this as like Windows Update. So it's going to install 3 little packages. And we can see that it's happy with that. I just need to put in my password again. That's because think of that as like a Windows run as. There we go. So we can see those packages now beginning to install. And that won't take too long at all. So that's now done. Now, the next command that I'm going to run is I'm going to tell Linux where it finds Docker. So when I say to Linux, go and install Docker, it's going to look at this as the repository of where it finds it. So again, sudo yum configuration manager, add the repository to where Docker is. So we'll go ahead and we'll add that. And now I need to update the cache. I'm going to go sudo yum make cache. Make cache. And that's going to go ahead and it's updating my cache for me. Brilliant. So that's now done. So with that, let's go ahead and go sudo yum install Docker CE. So now look, it's going off and it's saying, okay, should we install Docker? And I'm going to say yes. Yes. And Docker's going to install so I can run my pre-configured container. And again, just while this is installing, think of a container as the bit of the application that you're actually interested in. Normally when we install an application, we have to install all of the prerequisites. We have to install all of the other things. Well, with Docker, what I can do is I can just drop a container on top of my virtual machine, and I know that all of the underlying components are ready. They're already built. And it's super portable too. I created this image on my laptop. I then uploaded it into Docker, and I can run this anywhere I want. So we'll just wait for this to install. It shouldn't take too long. There we go. So we can see that Docker has now been installed. So let's go ahead and test this. Before I do this, I need to enable it. So I'm going to go sudo systemctl enable Docker. This makes Docker run when the machine starts up. I can spell. Like it. And we're going to say sudo systemctl and we'll start Docker. Okay, so Docker is now running on that machine. Let's go ahead and test it. And I'm going to test this with using the hello world. So I'll go sudo Docker run hello world. Now what's going to happen here is it's going to say, do I have this container running on my machine? If it doesn't, it's going to pull it down from Docker. It's then going to run the simple command in the container and then kill itself. And this will show us that Docker's running. So again, can't find it locally. I'll pull it down from Docker. It's going to run it to say, look, hello from Docker. This message shows that your installation appears to be working correctly. So now our Linux machine is able to run the Docker container. So to do this, let's go ahead and run our website. So sudo Docker run. I want to run this detached. Now, think of this like running an application minimized. On your Windows machine, you might have multiple applications open. You may have Outlook minimized, but you still receive emails, don't you? That's the same as this. I want to map port 80 to port 80. I'm going to name the container ACC-CNT demo, for the Accenture container demo, and I'm going to get this from Azure Dan, the doc repo, and the build a company in a day container. So again, can't find it locally. It's now going to pull that container down from Docker, and that's now running in my virtual machine. So again, if I take this public IP address, and if we paste that into here, we can now see that my website is now running in a Docker container. So far we have a virtual machine running Windows and a virtual machine running Linux. Now what we're going to do is we're going to build out some websites again, but this time we're going to do it using platform as a service. But before we dive in, we need to think about name resolution. Now, we've all used it. These are the names that make navigating the internet so easy. Again, computers like IP addresses, and if they had it their way, they would have us all using numbers to connect to the services that we love. And this would be horrible because we're hopeless at remembering lots of numbers. So DNS fixes this by acting as a large directory. And our machines will go through a process of name resolution to make sure that we get to the right destination. Take www.microsoft.com, for example. This is a naming hierarchy that starts at root, filters down to com, and then connects to Microsoft, which resolves the resource www. What we must make sure is that when we build our resources, we follow the rules of DNS. And this means that names have to be unique, they have to be lowercase, and they have to be properly registered to propagate throughout the system. So now that we have a better understanding of name resolution, we can begin deploying our PaaS resources. Let's start with a storage account. Now, on the surface, this may seem pretty basic, but storage accounts can achieve some pretty great things. You see, depending on how they're deployed, you have multiple options. We can create blob containers, which is where we can store our data. Now, these are not structured, so think of it like a great big bucket, but it's fast, it's cheap, and it's scalable. We also have tables. Tables are a no SQL store, which means that they're much cheaper than traditional SQL deployments. These are perfect for flexible data sets because they have no hard set rules. And again, think of things like device information or address books, metadata, or things like your like the Xbox league tables or your friend tables and things like that. Next, we have Azure Files. Now, Azure Files are an SMB cloud share, and this makes migrating storage connected applications to the cloud that much easier due to the fact that it's running an industry standard protocol. Again, when we push stuff to the cloud, we want to remove as much of the manual workload as possible, and file servers are a great place to begin the cull. Finally, we have queues. These are great for creating a reliable messaging stream between application components and super easy to scale. Now, you might be wondering, well, okay, this is fine, but is it secure? It's a reoccurring fear when people are considering cloud adoption. So let me put your mind at ease with a resounding yes. You have encryption at rest and client-side encryption, meaning that your data is protected and you hold the keys to your kingdom. So let's jump back into our demo and build out a storage account. Now, I'll build this out, but what we're going to do here is use the storage account to host our website. You see, storage accounts are a brilliant way to host simple pages, and seeing that they're so cheap, you can host them for literally next to nothing. So let's take a look. So again, back into my demo, I'm going to go into my resource group. And from here, I'm going to go into my marketplace and I'm going to look for a storage account. And again, look, storage account, blob files, tables, queues. So from here, I'll go create. Now we'll see that we still need to fill out a form, but the form's going to be slightly easier because we're using PaaS services. I don't have to give it as much information. What I do have to do, though, is I have to give it a storage account name. And again, this has to follow the rules of DNS. It has to be lowercase. It has to be unique. So I'm going to go ahead and let's see if we can have Accenture Demo Store. Let's see if that's happy. Yep, so we can have Accenture Demo Store. We'll host this in the US geography, the central US region. And I need to choose my performance. Is it standard or is it premium? Think of this as like SSD. This is standard hard disk. For what we're doing, standard is more than enough. For the account kind, do I just want it to hold blobs? Or do I want to be able to host tables, queues, and SMB file shares too? I'm going to leave it so it can access all storage types. In terms of replication, do I want it to be replicated inside the data center, between data centers, or between zones? I'm going to go ahead and say replicate inside the data center. This will create me 3 copies. In terms of the access tier, do I want it to be hot or cool? Again, think of this as disk, think of this as tape. You can access the information from both, but this will be much slower, but this is also much cheaper. I'm going to say hot for our demo. In terms of networking, I'm going to leave this public to everyone, potentially, but I could lock it down to only selected networks, or I could really restrict it only to private entities. From here, I'll say next for advanced. And you can see, look, do I want to enable things like secure transfer? Do I want to enable large file shares? Do I want to enable soft delete so I can undelete? Do I want that for my blobs? Do I want that for my files? Do I want to enable versioning so I can go back into different versions of the files? Do I want to enable data lake storage. So if I'm collecting massive amounts of data, do I want to turn it into effectively a data warehouse? So I'll leave the defaults. And again, I'm going to use my tags to say Microsoft Partners and Accenture. And then from here, we'll say next, review and create. We can see that validation has passed. So let's go ahead and build out that resource. Okay, so the deployment is underway. That's not going to take too long to build out. There we go. We can see that the store is now building out, and that should be finished relatively quick. And there we go. That's now done. So let's go ahead and look at what we've got. If I click into the storage account, we can come down and we can see, look, I can build containers. Now, this is a stupid name because people will often get confused with compute containers. This is not the same as what I've just installed on Linux from Docker. When we're talking about containers in storage, this is what they mean by the blobs, the binary large objects. Okay, so just think containers, this is the blob. We've got our SMB file shares, our tables, and our queues. So I'm going to go ahead and build a container. But before I do that, let's just take a look down the left-hand side. Now, again, things you would expect, identity and access management, tags, events, and so on. I've also got Storage Explorer. Now, Storage Explorer is like a cloud file server. It allows me to go through my different storage types and manipulate the files if need be. If I come down to settings, this is where I configure my access keys. Now, when I create storage accounts, I don't have NTFS permissions. I don't have things like that I can set. So when I want something to access the resource, they have to have a connection string and a connection key. So think of this as like the username and password to be able to access it. As you see, there's no permissions in here. This is full access. So if you do find that you need something a little bit more restrictive, you don't use an access key, you use something called a shared access signature. Now, a shared access signature enables you to define what services you're allowing, the resources you're allowing, the permissions you're allowing, for how long you're allowing it for, and from what source. Okay, you can also choose any protocols that you want to use. So again, this is full unrestricted access. This is locked down, timed, and contained access. Okay, so let's go down into containers. So if I go into containers, I'm going to go ahead and create a new container. Now, again, under the public access level, I'm going to say that this is anonymous, and I'm going to go ahead and call this images. Okay, so I'm going to create one called images. Now, this is going to create me a public container, and what I can do is then I can upload anything I want into it. So if I go into save pictures, I thought I had an Accenture one in there. Okay, for this one, let's just use Sophos just for this demo. But if I put Sophos in there, okay, what that then gives me is it gives me a URL that I can access from across the internet to access those resources. Okay, and we can see that I've now got that up and running in the cloud. But you'll notice that it isn't particularly a nice URL. Okay, it's accdemostore.blob.core.windows.net/images/sophos.jpg. So it's quite long, and most companies are going to want to use a custom domain. But of course, we can do this. If I go back, you can see that I can put my own custom domain in there. I can also add data protection. And I can also add what's known as a content delivery network. So if I'm pushing out a resource that I need to sort of serve, thousands or millions of people across the globe, then I don't want them all accessing one endpoint. If I push them out to Microsoft's CDN network, then they will have locally cached copies close to them. so they can access those resources much faster. What I do want to do though is I want to have a look at this. You see, we talked about hosting a website. So if I click on static website, what I can do is I can enable the website to be hosted inside the blob service. So I'm going to go ahead and enable this. I'm going to say that my index document will be called index.html. And I can also put in a 404 error document as well. I'll leave that as that and say save. Now, what's going to happen is this is going to create me a primary endpoint. And if I copy this and paste this into a new window, we can now see that we've got a website hosted in the cloud. Now, obviously there's nothing in there, but it does exist. So let's go ahead and put our website in there. To do this, I'm going to go up and I'm going to go into Storage Explorer. Under blob containers, you can see that I've got the web container. So what I'm going to do now is I'm going to upload, and I'm going to choose to upload my documents, my files, and my index.html directly into that storage account. And then from here, if I hit a refresh, you can see that my website is now running in the cloud directly from a storage account. So here and here I've had to run a Windows machine. It's only running a website, but it means that I've got to pay for that virtual machine to be running 24/7 just so people can access this website. Here, I'm running a Linux virtual machine, running a container. Now, it was slightly easier to configure, but it does mean that I've got to be running that virtual machine 24/7 to host that container. Here, I'm hosting that website on a storage container. And with storage, you're only paying for the resources that you consume. So I'm paying for 893 bytes of information. And you can imagine how cheap that is. This was going to cost me $150 a month. This probably won't cost me $150 in its lifetime. So you begin to see the power of platform services as we move across the stack. Okay, so before we go back to our slides, I just want to show you one more thing. And again, I want to go back to hosting a container, but I want to host a container using platform services in the cloud. So I'm going to do this using an Azure container instance. So again, I'm going to go into resources and I'm going to click on add to take me into the marketplace. And from here, what I want to do is I want to look for a container instance. Okay, so I'm going to look for a container instance, and an Azure container instance is the fastest and simplest way to run a container in Azure. I don't need to have to provision any virtual machines, and I don't need anything like Kubernetes or anything like that. So just to put it into perspective, because I'm running a single container, I can do it simply using an Azure container instance. If I was running hundreds or thousands or millions of containers, I would need a separate management plane. And this is where we use things like the Azure Kubernetes Service, AKS. So I'm going to go ahead and hit create. Now, as I do this, like before, I need to give the container a name. So I will call this Accenture ACI Demo. And I'm going to choose that I want to host this in US, Central US. Now, again, what do I want? Do I want to use a quick start image? Again, look, the hello world. Or do I want to use a Windows web server? Do I want to use a Linux Nginx web server? I'm going to choose that I want to point to my Docker hub. I want to use a public image, and I'm going to point it towards Azure Dan. Doc repo, build a company in a day. Okay, so there is our Docker repository. Here is the container we want to use. It's going to be running Linux. I don't need it to be this big, so I'm going to change size. I'll say, well, 1 core, 0.5 gig of RAM. That should be fine. So we'll say okay to that. For networking, we'll make it public, and I'll give it a DNS name of Accenture ACI web. Okay, so we've now got a DNS label. We're going to make sure port 80 is opened, and then we'll say next for advanced. For my restart policy, we'll leave that on failure. Now, if I wanted to add any environment variables, let's say I wanted to connect it into the storage account. Let's say I wanted to connect it into some back-end services. Here's where I could put the keys and values. I'm going to say next for tags. Like before, I'm going to say MSFT partners and Accenture. And then from here, I'll say next for review and create. And when validation has passed, we'll begin to create that resource. So that's going to take a moment to deploy. It's going to pull that stuff down from the cloud. And then when it's done, I'll be able to access that container directly from PaaS. Let's just give that a moment. I'm just looking at the chat window. It doesn't seem to be any questions. So if you do have any questions, please feel free to put them in.
Questa non è mia voglia. Sì. Ma che dove? Questa è in giro con una bambina. No, poi ci mandavo le relazioni.
Okay. Getting a little bit of feedback, so can we just make sure that everyone's mic's muted? Okay, so our deployment is complete. Let's pin that. We pin that to the dashboard. Oh, no, I didn't. Okay, so let's go back into my resource group. Let's pin that to the dashboard. Brilliant. And we can see that that container instance is now up and running. So with that, let's take a look at it. So if I go into my container instance, you can see that I can look at crude overview of what resources it's using. I've got my fully qualified domain name. So let's paste that into a new window. I can now see that my container is running in an Azure PaaS instance. So you see, look, how much easier it is to run these things in PaaS, how much cheaper it is to run these things in PaaS, as opposed to having to do it in infrastructure as a service. You now have 4 instances of that website up and running. Okay, so let's now look at another way that we can do it. And we're going to do this with Azure Web Apps. Now, Azure Web Apps are also a great way to host content on the cloud. It's part of app services, and they're used to host things like web applications or application programming interfaces and mobile backends. Now, our application can be either code or, again, it can be container-based, and it can be deployed on both Windows and Linux kernels. But unlike IaaS virtual machines, we have no visibility of the operating system because it's platform services. But it also means that we have no responsibility in managing the underlying infrastructure. We simply focus on the application and its underlying runtimes. App services add security, load balancing, and auto-scaling alongside automated management solutions, and allows developers to take advantage of several deployment methods. They also sit on top of what's known as an app service plan. Now, this is where you specify the CPU, the memory, storage, and service commitments, and the prices will then be reflected accordingly. So let's jump back into the portal and host our website one last time. Okay, so back into the portal, I'm going to go into my resource group. I'm going to click on add. This is going to take me into my marketplace, and I want to look for a web app. Okay, so we can see we've got web app here. So I'm going to select web app and go ahead and hit create. Now from here, as the form opens, like before, select my subscription and resource group. I need to give it a unique name. This needs to be unique inside Azure Websites, inside the .NET. So it's root, net, Azure Websites, and the name that I put in. So I'm going to put in Accenture DApp Demo. So essentially a web app demo. I'm going to say that it's code, but again, I could point to a Docker container. But I'm going to say it's code, and I'm going to select my runtime stack. Now, you can see I can choose .NET, ASP, Java, PHP, Node, anything that I want, Ruby, Python, and so on. For our demo, it really makes no difference whatsoever because we've got simple HTML. So I'm going to say Windows. We'll put it in Central US. Now, as I said, the web app sits on top of the app service plan. This is where we choose the resources that we want to commit to. This is where the price comes in. So let's have a look at the different sizes we've got. If I go into dev test, we can see that I can run an F1 instance. And as you can probably guess, this is free. Okay, so you can run a website in Azure and it won't cost you a penny. This will give me a gigabyte of memory and 60 minutes of compute every day. Now, again, do bear in mind, that doesn't mean that the website is going to run for an hour and then turn off. You see, if I go back to my virtual machines here, even if nobody accesses the website, I've still got to pay for compute to keep those virtual machines running. But if I look at PaaS services, if no one accesses it, there's nothing to process. If there's nothing to process, there's nothing to pay. So you get 60 minutes free. Now, if I go into a shared infrastructure, this is going to start costing me about £7 a month. Okay, but here I can start adding my own custom domains. If I go into the B series, you'll notice that I can add custom domains and SSL certificates, and I've got the ability to manually scale. Now, do bear in mind, the reason you've got the ability to manually scale is because you're in a dev test environment. As you move into production, scale becomes automatic. But if you're doing stress testing, it's very hard to stress test a machine if the cloud service just keeps adding more resources if it needs to be. This is where I'm sure you've tried to buy tickets in the past or, for a concert or an event. And, it says the tickets go on sale at 10 o'clock and you go to log in at, 10 o'clock and the whole website has crashed and gone down and you end up frustrated. That's because it's running on physical tin and it's maxed out its resources. It simply can't cope with the demand. Well, that will never happen in a cloud environment because as it gets stressed, it will just keep adding more resources. If I go into production, I'm going to choose an S1. And you'll see that will give me custom domain, SSL, auto scale. It will give me daily backups, but it will also give me things like staging slots. Now, staging slots are amazing, and we'll take a look at this once it's deployed. But staging slots allow me to run multiple versions of my website and then swap them into production when I'm ready. So it gives me change control. You'll see that I can run premium versions of this, and I can also run isolated dedicated tin if need be. But it's important to remember that if I pick this S1 here, I've got 1.75 gig of memory. I've got a whole bunch of compute that I can use. But that doesn't just mean I can run one website. I could run 10 small websites on top of this. So this is the compute. This is the portion of the compute you're buying. What you put on top of it is completely up to you. So let's go ahead and say apply and say next for monitoring. Now, I'm not going to enable application insights, but this would enable me to get a good overview of what was going on that web app service plan. It would allow me to see who was connected in, what browser they were using, how long it took them to navigate pages. So it would give me rich insights to how well my service was performing. So I'm going to say no. And then I'm going to go into tags and I'm going to add MSFT partners and Accenture. From here, we'll say review and create. And we'll begin building out that resource. So again, that'll take a few minutes to deploy. You can see the deployment's underway. It shouldn't take too much longer. And there we go. That deployment is now complete. So if I go back into my dashboard, just customize that, and we go into our web app. So into my web app, again, you'll see that I've got a URL. If I click on the URL, it's now going to open up my website. And we can see that it's not the web page I want, but a website is currently up and running. Brilliant. So with that, let's take a look at how we can configure it. And as I come down on the left-hand side, you can see I've got things like deployment slots. With deployment slots, this is what I was saying before. I've got my production, but I can create up to 10 sub-slots. This will give it a different URL and allow my developers to work on different versions. So let me show you what I mean. If I click on Add Slot, I can create a version 2 and hit Add. And when I do this, it's going to go ahead and create me a different URL, but it's sharing the same resources. It's sharing the same CPU and memory and disk of the app service plan. So that'll take a moment to build out. There we go. And I've now got a version 2. And if I click on version 2, you can see that it's got a different URL. So I've got my ACC web app demo, and I've got my ACC web app demo -v2 Azure websites.net. Okay, so I've got 2 different URLs, 2 different versions. Now, let's see why this is important in a moment. We're going to go back to production. But as we do that, let's look at Deployment Center. This is how we're going to update our code. Now, do I want to do it manually? Well, for today's demonstration, I am. I'm just going to do it live in the portal. But I could use FTP. I could push it up into OneDrive or Dropbox or anything else. But if I'm doing this as a bigger deployment, then I'm probably going to be using things like, you know, Visual Studio or GitHub or Azure repositories. And this is what's called CI/CD, continuous integration, continuous deployment. So I can configure this from there. In terms of configuration, remember, this is platform services. I'm not able to RDP into a virtual machine, but I can still do all the configuration that I need from the portal. So I can still go in and I can add any application settings or connection strings. So again, if I wanted to connect into any of those services, I could add those connection strings here. If I wanted to, you know, set the general settings, like what stack or what platform, or am I going to allow FTP and so on? Do I want to choose any path mappings? What about authentication? Now, at the moment, this is wide open. Anyone can access it. But if I was building a service that I wanted people to authenticate into, this is where I could set it here. And again, it's worth bearing in mind that I'm building a website, but this could also be a mobile application. Let's say, I don't know, let's say I was building a dating app. You know, I could build my mobile front end. I've created my storage for my images storage account. I can connect that in using the application connection strings, but now I want people to be able to log into it. Well, the first thing that I could do is I could create them all a user account, which, let's be honest, if it got popular, would be a nightmare to do. So if I go into authentication, because this is cloud, I can take advantage of cloud connected security graphs. So I could simply turn on authentication and say, well, look, I want you to authenticate using Facebook or Google or Twitter or Microsoft Live or Azure AD. So I've got the option to choose how people authenticate. We talked about the application insights. You know, we know what backups are, but do I want a custom domain? I don't want them to be connecting to ACC web app demo.azurewebsites.net. Maybe I want them to be connecting to, you know, accenturedemo.org. So I just search for it. Look, accenturedemo.com. Or let's just say Accenture Demo, see what it comes back with. If I go ahead and search for that, it will have a look and it will say, well, these are the domains that you can have. Okay, so these are all of the domains that are kind of like it. If you pick the one that you want, then what will happen is, as soon as I say OK, Azure will buy the domain, it will configure all of the DNS for me, and it will update all of my resources, and that's it. That's all I need to do. And it's exactly the same when I look at things like SSL certificates. I just go in there and I say I want a digital certificate, and it will make it HTTPS. If I come down, we can see about scaling up. Now, if I don't want to make it, if I want to move it into premium, I can do that. But again, there's a big but here. In the past, to me, this is the old way of doing IT. In the past, when it was all on premises, we would just keep throwing resources at the tin. Being a cloud world, we don't want to scale up. We want to scale out. We want to create multiple instances of it. So instead of just having, bigger and bigger and bigger, have multiple instances running that workload. Because when you think that way, you can create custom auto-scale policies. And you can go in and say, well, look, I want to add a rule that when CPU goes over this value for this amount of time, add another instance. If CPU falls below this value for this amount of time, decrease an instance. This means that you always have the right amount of resources. And if you need more, it will consume more. If you need less, it will consume less. By doing it this way, you're only ever going to be paying for the resources that you need, and you're not going to be paying for resources that you're not particularly using. So if we come down, how do I access this website? One of the development tools, if I go into console, we can see that I can open up a command prompt in the cloud. From here, I can start navigating my website. But probably what I'd want to do is go into an app service editor. Now, an app service editor gives me a live view of my website that I can then begin to manage. So we'll wait for this to open. And we can see my website is here. So what I'm going to do is I'm going to now upload my website. Let's open this with Notepad. Let's copy that code. Let's delete this and paste that new code in. There we go. So I've now got my new code up and running. I can close that down. And when I hit refresh, we can see that my website is now running in the cloud. So that's my production one, but I've just noticed this is saying build a company in a day, and I want to change that. So this is where the deployment slots come in. If I now scroll back up to my deployment slots, if I go into version 2, I can then go and make the edits that I need. So I can go into my app service editor. I can make the changes that I need, and then I can simply swap it into production. Okay, so back into that source control. That's Control A, Control V, and I'm going to change the title to Accenture Azure Azure Demo, and we can close that down. Now when I hit a refresh, there we go, the Accenture Azure Demo. That's more like it. Now I need to get this version 2 into production and the one in production back into storage. So again, how would you do that? In the past, that's going to mean updating DNS and everything, but not in Azure. In Azure, all I'm going to do is I'm going to click on my deployment slots, and I'm going to hit swap. And I'm going to choose to swap the source and target. And what will happen is Azure will control everything for me. Excuse me. So we'll just give that a second. It's performing the swap, and what we'll see is in a moment, this will change. And this one should change too. Let's just hit a refresh. There we go. So that one's now saying Accenture Azure Day. This one, if we hit a refresh, just give it a bit more time. we go. And that's now changed to build a company today. So version 2 is now build a company today. Accenture Azure demo has moved into production, and we can see the swap is now complete. So that's how easy it is to run different web workloads in the cloud. And I think at this point, I've shown you enough of running websites. So for the last sort of part of this demo, I think what we'll do is let's switch things up a little bit and look at maybe a little bit of serverless computing and artificial intelligence. Now, before I do that, can I just ask anyone, is anyone on Twitter? Because I'm going to need your help. If you can just put it in the chat window for me. Okay, so for those that are on Twitter, I'm going to need your help in a moment. I'm going to need you to send out a tweet. Not yet. I'll tell you when to do it. And what we're going to do is we're going to use artificial intelligence to analyze the tweet and decide if it's positive or negative, and then send me an email based on that. So Kevin said you're on Twitter. Kevin, are you okay for us to use you as a guinea pig for you to do a tweet, and then we can see the information? Brilliant. Okay, awesome. So let's begin building this out. So back into my dashboard then, let's talk about what we're going to do. So we're going to build a logic app. Now, in my mind, logic apps are the best things ever. They're easy to build, they're cheap to run, and they connect to a whole bunch of cool services. I mean, they will help you schedule, automate, and orchestrate tasks, processes, and workflows by using 3 things: a connection, a trigger, and an action. Take this simple solution we're about to build. So I'm going to connect my logic app into Twitter. I'm then going to get it to look for a particular hashtag that Kevin is going to use. I'm then going to get it to send any related text that Kevin has tweeted into AI so that it can evaluate the message and then determine if it has a positive or negative sentiment. If it finds a positive tweet, I'll ask the logic app to write an email and forward me the Twitter name and message to my inbox, along with how many people Kevin has influenced with his message, and finally the sentiment score. Right, okay, so let's go ahead and build this out. So I'm going to go back into my dashboard and into my resource group. Now from here, what I need to do is I first need to add my cognitive services. Now, cognitive services, think of these as pre-built Microsoft artificial intelligence that we can simply plug into. So if I look for text analytics, okay, we can see that text analytics will allow me to gain insights from any unstructured text, okay, using natural language processing. So I'm going to go ahead and hit create. Now, to do this, I need to give it a name, and I'm going to call this Accenture TA Demo. Hopefully that's happy with that. So yes, it is. I'm going to store this in US, Central US. And for the pricing tier, I'm going to say free, because we're only doing a short demo. So 5,000 transactions every 30 days. That's going to be more than enough for what we need. Okay, and I could probably just keep running this for the amount of volume I'd expect. So I'm going to say free, and I'm going to make sure it goes into Accenture. And with that, I'm just going to hit create. There's nothing more to do. Like I say, Microsoft's done all the hard work. Microsoft has done all of the training of the model. I just need to plug into it. So once it's built out for me, all I'll need to do is need to grab a couple of bits of information. So with that, we can see that's done. Let me just open up Notepad because I need to grab a couple of bits of information from it. So from here, let's connect into cognitive services. I'm going to grab the name. And then I'm going to grab, if I come to the keys and endpoint, think of this again as the username and password. to connect in. So the endpoint, that's where I will find the service, and the key. Let's copy that key and we'll paste that in. So there's the 3 bits of information that I need. With that done, then if I go back into my dashboard, back into my resource group, I'm going to go ahead and click on add. And this time I'm going to build myself a logic app. Now again, I love logic apps. These things are the best things ever. And you've probably used something like this if you've used Power Automate or Microsoft Flow or services like If This Then That. That's pretty much what logic apps are. So again, in Microsoft Partner Demos, Accenture Resource Group, for the logic app name, I'm going to call this Sentiment Analytics. Okay, and I'm going to store that in Central US. And then we will give it the tags as before. So MSFT Partners and Accenture. And then from here, we can create that resource. Okay, again, resource is done. So we'll pin that to the dashboard. And let's connect in. Now you'll notice that as we connect in, this will take us into the designer. And you'll see that there's a whole bunch of common things already there. There's a whole bunch of templates already there. You know, delete old blobs, you know, you see that, get daily reminders. There's a whole bunch of stuff that you can use. But it's super, super easy to build these out. So we're going to go ahead and use a blank logic app. So the first thing that I'm going to do is I'm going to connect to Twitter. So there's my connector, and my trigger is going to be when a new tweet is posted. So what I need to do now is I need to connect into the Twitter API. So to do this, I'm just going to sign in. Again, this is where the demo can go horribly wrong because I honestly can't remember what my password is, but let's see if I get lucky. Right. Oh, actually, has it saved it? That would be brilliant if it has. Oh, brilliant. Okay, so I didn't have to remember. So I've connected into Twitter. And what I'm going to do is I'm going to search for the hashtag ACC Azure demo. So Kevin, not now, mate, but what I want you to do is in a moment, if you can put that in the chat window. So ACC Azure demo. That's the hashtag I need you to use. I'm going to get it to check every 3 minutes, but don't send it yet. I'll let you know when I need you to send it. So ACC Accenture demo. We'll check every 3 minutes, or we can check, you know, let's say once an hour. So every hour, check for that hashtag, because I'm going to manually invoke this anyway. Now, if you find anything, we need to create a new step. We said we want to send this down into text analytics. And what I want to do is I'm going to send it down into text analytics so it can go ahead and detect the sentiment of the tweet text. So again, now I need to connect into that text analytics. And I'm just going to put in those 3 bits of information. So my connection name, my account key, and the endpoint URL. They're the 3 bits of information that I need. Let's go ahead and hit create. And once it's done that, once it's plugged into that cognitive service, I can then add a new parameter. And I say, right, I want to analyze some text. Now, here's where you'll notice that it's now connected into the Twitter APIs. And these are all the things that Twitter are going to allow me to investigate. So I want to go ahead and I want to look at the tweet text. So I'm just going to select the tweet text. So I've selected the tweet text. Now, once it's done that, I'm going to go ahead and create a new step. Now, at this point, I want to add a condition. I want to put some logic into it. So looking for a hashtag, sending it down into AI. Now let's add a condition. So I'm going to add a condition. And I'm going to say if the score, okay, so if the score is equal to, or what I'm going to say is greater than or equal to 0.5. Now, 0 is bad, 1 is good. This is standard binary. So 0 bad, 1 good. So if it's in the middle, I'm going to say if it's equal to 0.5 or greater, then we're going to do something. But you'll notice that we could have a false. In fact, if you follow me on social media, most of my posts are done by a logic app. Most of my tweets, most of my LinkedIn posts are all done by artificial intelligence that pushes it, or automation that does it on my behalf. But I also have another one that looks at the responses from my followers. And if it's positive, it goes into a database that I can then show my boss. And if it's negative, it will send me an email so I can see, you know, how many people they've influenced and whether or not I need to chase it up. So I'm going to go ahead and I'm going to say, well, if Kevin says something nice, I'm going to get it to send me an email. So I'm going to say we're going to use Office 365 and we are going to get it to send me an email. Sorry, my screen resolution is quite high so everyone can see this. So I'm going to get it to send me an email and I'm going to sign in to my Office 365. Now, I've got a special account set up for this. And we're going to connect into Twitter at azuredan.net. So let's sign into this. Okay, then from here, we're going to send myself an email. I'll send it to myself. So just Twitter at azuredan.net. And we're going to say, check out this awesome tweet from, and then all I'm going to do is I'm going to put in the name. Okay, so the name of the user. And then in the body, I'm going to put, check out this awesome tweet from, again, let's put name in. Who said, let's put text in, so the tweet text. And influenced, let's put in the follower count with a score of, let's put in score, and that looks good. So check out this awesome tweet from so-and-so who said what they said and influenced how many people with a score of what the sentiment score was. So I'm going to go ahead and hit save. I'm then going to go ahead and hit run. So Kevin, this is where you come in, mate. So if you wouldn't mind sending a tweet using the hashtag that I put in the chat window, so hashtag ACC Azure Demo. Now just create a sentence. You can put, you know, you're having a good time, you're having a rubbish time, it's a brilliant presentation, it's a rubbish presentation, anything that you want. And then what will happen is I'll be able to show you how artificial intelligence and the Logic app has been able to intercept that. So if I go back, I'm going to run that trigger that when a new tweet is posted, and we can see, look, we've got a success. So I'm going to go ahead, I'm going to click on it, and we can see that I've got 4 ticks. So the flow has worked perfectly. So let's take a look at this in detail. And again, apologies for the screen resolution. I'm just trying to make sure everyone can see it. So when a new tweet is posted, and we can see, look, Accenture, Azure Demo, hi everybody, interesting stuff then, okay? It's then, we can see when it was sent, no one's retweeted it yet. Okay, we can see who it was tweeted by. We can see the media URL. Okay, we can see the full name, ID, follower count, and so on. Now, that information was sent down to detect sentiment, and it was scored as 0.98. Okay, so Azure thought that was pretty positive. So what it's done is it said, well, okay, I think that's okay. It's got a high score, so that must make it true. And then what it's, I can close this down a bit. What it's then done to connect back into that. Apologies. Just struggling with screen resolution. What it's then done is it's sent an email, and we can see, look, to twitter@azuredan.net. Check out this awesome tweet from Kevin. Then check out this awesome tweet from Kevin, who said, hi, everybody, interesting stuff, Dan, and influenced 31 people with a score of 0.98. And what I'll do is if I open up an in-private session, and if I connect to Office 365, sign in. Sign in as Twitter at azuredan.net. Okay, we're in the right password. And what we should see, I go into my Outlook, that I have indeed got an email from Kevin, and it's come up with the information that we put into the Logic app. So again, look, I've just done this really, really simply, but I hope you can see that with a little bit of effort, you can do some amazing stuff with this. I got it to send me an email, but this could go into your CRM. This could go into your Teams window. You know, we could make sure that if you're sending out a new product or a new service, you really get to understand how well it's landing. You really get to understand how well your sort of customers are responding to it. So with that, let's start to wrap things up. So let's close these things down. We've seen enough of these now. Let's go back into our portal, back into our presentation. Okay, so we're getting to the end of the webinar. Again, I hope I've inspired you to sign up and build out some of these resources yourself. But also want to highlight that we've got some great support available, and I want to show you some of the services that you might try. Now, before I do that, I think it's prudent that we cover the levels of service because they all build on top of each other and offer increased levels of benefits as you move up the tiers. Now, obviously, Accenture, you are the highest tier. You are, you know, the professional director, and more than that too. But it's important to know this, especially if you're going to do the exam. Now, fundamentally, everyone gets access to basic support. This includes access to billing and subscription support, documentation, and forums. You also get personalized service health dashboards and access to health APIs. Again, we'll look at this in a moment. The developer tier, which is for non-production purposes, will include everything previously mentioned, plus access to support engineers over email and some general guidance for architecture designs. As we move into production workloads, we have the standard plan. This will enhance your service level agreements with faster times to resolution with both email and telephone support. And then finally, you have professional direct, which again speeds up your SLAs, in addition to providing you with onboarding services, consultations, and service reviews. So with that, let's jump back into the portal one last time and see how this works. So again, we've built out all of our resources. Let's look at some of the ways that we can troubleshoot this for the last sort of 10 minutes. If I go into my left-hand side, if I come down, you can see that I've got service health. If I go into service health, we can see if there's any service health issues. And you'll notice that I can filter by my subscriptions, my regions, and I can select the services as well. And at the moment, we can see 169 services, 41 regions, and issues resolved in the last 7 days. So we can see that there were some issues. There was an issue with application insights. So if I click on this, it's going to give me a breakdown of what was happening. Let me try and clean this screen up a bit. You can see what was happening. So there was a problem with application insights in East US 2. Okay, it impacted my website, azuredan.co.uk. Okay, but I can look at the root cause and what happened. I can download the issue summary as a PDF. I can track the issue on my mobile. I can look on social media to see what's going on. But the other thing that I can do is I can also create my own service health alerts. You see, maybe I'm not interested, in application insights. Maybe all I'm interested in is what's going on with my app service and web app. Maybe I'm not interested in what's going on all over the world. Maybe I'm only interested in what's happening in central US. So I can begin to filter this down. I can then pin this directly onto my dashboard. I can create a service health alert to say, well, okay, if this does happen in this context, then go ahead and do this. I create an action group that says, you know what, send me a text message, send me an email. Just let me know what's going on. And I can configure different application groups for different severities and different times. Okay, I've got things like planned maintenance. So if there's any planned maintenance going on any of our physical servers or any of our data centers, it will be shown in here. I've also got the option to look at things like health advisories. Now, this is where artificial intelligence is going to be looking at my resources and saying, well, you could perhaps look at doing this. And it's the same with security. So it begin to look at this. If I look at health history, I can get a breakdown of, things that have happened. So again, subscriptions, I can, let's select all. Let's look at what's happened over the last 3 months. So over the last 3 months, here's the things that have happened in Azure. So we can see that I've had 1, 2, 3, 4, 5, 6 things that have gone on. So Azure Resource Manager failing. Okay, so between 7:45 and just shy of 5 o'clock on the 4th of June, a subset of customers across all public Azure regions may have experienced deployment failures when attempting to create or delete certain services. So again, what it was, what they did, the updates, the summary, the root cause analysis, and again, you can download it if you need be, in case it affects any SLA agreements and so on. So again, the service health dashboard is brilliant. You've also got things like help and support. If I go into help and support, here's where I can create a new support request. Again, you've got your support plans that we talked about. So here's your free, your developer standard, and so on. I can go ahead and create a new support request. So from here, what type of issue am I having? And then it will filter me through to make sure that I'm talking to the right people. I can monitor all of my support requests. I've got access to service health if need be. And I've got access to the Azure Advisor. Just take a quick look at this. Now, the Azure Advisor looks at 4 key areas. It looks at cost, security, performance, and operational excellence. Okay, so cost, security, operational excellence. Oh, it's actually 5 now. High availability and performance. And from here, we can see, well, at the moment, we think we're paying the right amount. Nothing seems to be untoward. We can see high availability. We've got some recommendations. We can see I've got some recommendations for operational excellence, and we can see I've got quite a few recommendations for security. So even in the space of the 2.5 hours we've been presenting, Azure is now starting to identify by using artificial intelligence the things that I could have done perhaps a little bit better. And let's go ahead and look at this. So if I go back and look at the Security Center, this is now going to start giving me a breakdown of all of my security, compliance, and resources. So if I look at this, I can see I've got a security score. If I click on my security score, I can see that looking at my subscriptions, if I look at my Microsoft Partner demos, I have done I've got 4 out of 14 points. So pretty much terrible. Okay, and these are the things that I need to look at. So I need to look at things like enabling multi-factor authentication, because at the moment, anyone can log into my demo subscription. You know, if I'd been doing this on my Microsoft subscription, I would be, you know, I'd be shot by now because I'd have to use multi-factor authentication. But we can see that it's recommending what I do. If I go back, not only is it recommending secure score, but it can also look at regulatory compliance. So if I wanted to look at my resources and say, well, okay, how do I make it, you know, payment card industry DSS compliant? It will look at what I've done and it will say, well, look, you've got a few things to do. Let's not use vendor supplied defaults. Let's look at encrypting transmission. And it gives you all of the information that you need to do to be able to remediate it. But here's where this gets really cool. Not only is it identified it, not only is it telling you what's wrong, it will also fix it for you as well. Look, quick fix. So you can go in, you say, right, secure transfer to storage account should be enabled. And if you click on it, okay, this one, remediate. So not only has it identified the problem, it would allow you to fix it just by going, oh yeah, okay, fix that then, remediate that for me. And that's the power of AI. It's looking at those resources and then it's recommending the things that you should do. If I go into resource security hygiene, we can see that I can, you know, look at a breakdown of what's going on. So I can see that, again, I've got my points that I need to do. So enable multi-factor authentication, secure management ports, apply system updates, enable encryption at rest. You know, things like apply adaptive application control. And this is what they mean by application whitelisting, to make sure that only certain applications will run. You know, protect applications against DDoS attacks, enable auditing and logging. All of these things that we can start to configure, all of these things that we can start to build out. Yeah. Okay. If I come down, I can look at these by resource health too. So I can look at compute, I can look at data and security, I can look at identity and access. And again, on the left-hand side, I've got the ability to focus into all of these too. So if I click on compute and apps, for example, just wait for that to wake up. Look at compute and apps, it's telling me some of the things that I should be doing. I should have disk encryption enabled. Okay, management ports and virtual machines should be protected with just-in-time network access. This goes back to what I was saying earlier. You know, that Windows virtual machine. Anyone can connect into that Windows virtual machine. So if I click on this, we can see VM1. Let's just open that. Let's quickly click on that so I can nick the IP address. Go back. If I click on VM1, like I say, at the moment, anyone can connect into it. I can open up a Microsoft Terminal Service connection. I can paste in that IP address. I can hit connect, and it's going to allow me to connect into that virtual machine. But that means anyone with that IP address can potentially start doing a brute force attack on that virtual machine. So what I can do here is Azure Security Center has said, well, look, let's fix it. And I can do this by hitting remediate. And when I hit remediate, what it will do is it will invoke just-in-time VM access. And this is where the cloud is then going to start dynamically opening and closing those ports. So I can say, right, port 3389, let's open it on request, but let's only open it for internet. Let's only open that for an hour. And it has to be using TCP, and it has to be from a particular IP address range. I can put all that in. So if I say OK to that and then hit save, what's going to happen is just-in-time VM access is now going to start locking down that resource. And it means that that port won't be dynamically opened, which means when I do want to access it, I need to justify it in the cloud. It all then becomes an audible event. It all then becomes change control, change tracking. So as that builds out, and that'll take a little while, it'll take a couple of minutes, but what we should see is that I won't be able to access that virtual machine. So with that, let's just make sure, let's see if we can connect in. If I hit connect, now we're seeing that that's now blocked. You see how it won't allow me to connect into that virtual machine? So artificial intelligence has now automated the lockdown of those ports. So if I do want to access it, what I've got to do is I've got to justify it. So I need to go into just-in-time VM access, and I need to say, I want to access virtual machine 1. So now I've got to request access. I've got to request that I want port 3389 open, and it's going to be open for an hour. I mean, I can try and change that, but I've locked that to an hour. So from here, I'm going to say, well, look, let's go ahead and open the ports. But notice I can also put a justification in. I need to make changes to that website. Okay, and then I can go ahead and open that port. Once it's validated, okay, it will be sent again into Azure. Those ports will then dynamically open, and I'll be able to connect into that service. So let's just give it a moment. So with that, let's try and connect into this one last time. And there we go. Look, artificial intelligence has now opened up that port, and we're able to connect to that machine. So with that, we're just shy of the 3-hour mark. Thank you very much for your time. I'm happy to hang around if there's any questions, if there's anything you've got or need answered. Other than that, thank you very much for your time, and I will get this video sent out to you.